This week, we looked into boundary truncation techniques. Starting with the motivation, we discussed some of the commonly employed boundary conditions in numerical simulations. This includes bulk interface, special interface, and absorbing boundary conditions. Under special interface condition, we studied perfect electric and perfect magnetic conductor boundary conditions. We studied both the one-dimensional and two-dimensional mathematical formulations of Engquist-Machta absorbing boundary condition, paying special attention to the respective reflection coefficients calculations. Later, we introduced the mathematical formulation for the famous Berenger perfectly matched layer technique. We examined the role of lossy terms in the update equations and how one can optimize these losses for a good PML performance. We demonstrated the efficacy and accuracy of the PML technique for a couple of practical applications, namely horn antenna and waveguide simulations. Following this, we discussed at length the mathematical formulation of the uniaxial perfectly matched layer technique. And we also discussed its advantages over classical Berenger perfectly matched layer technique. We ended this week's lecture with some numerical simulations to test the accuracy of uniaxial PMLs. As an example, we demonstrated using scattering applications with a point source incident on a scatterer. With this week, we have come to the end of the finite difference technique that we have discussed in the last few weeks. In the next modules, we will introduce variational method, which is the basis for finite element and the method of moments. Please practice the examples and simulations that we discussed this week. Post your questions on the forum and get ready for the next week. Until then, goodbye.